Okay, what we want to do now in this next video is we want to continue in section 2.1. This is part 4, and this is still solving equations. And the kind of equation that we've been talking about solving, this is the first time you've heard this name, but all of the equations that we've been solving up to this point falls under the title linear equations. A linear equation is just simply an equation that has one letter in it, and it's to the first power. So you've got an equation that has one letter in it. Now, it may be listed in multiple places. You may have an x over here and an x over here and a plus 3x. And so the x may be listed multiple times, as you've seen in some of our problems. And there may be some numbers in the problem, but it's always one letter, no more than one letter, and that one letter is always to the first power. And and then, of course, the equal sign. So all of these problems we've been dealing with are called linear equations in one variable. What we want to look at now in this next part of the equations is, what do we do with an equation if it has a fraction in the original problem? Well, the good thing about an equation is if you have an equation that has fractions in it initially, we can eliminate all of those fractions right out of the gate. First step. Now, different teachers teach this differently, so depending on who you had, and really, I'm not necessarily saying that the way I'm going to show you is the best way. It's the easiest way that I have found over my years of teaching that students pick up on it quickly, and they like it a little bit better because we can get rid of the fractions the first step. So if you've learned it a different way and you go a little bit different route, as I said before, as long as you're getting the same solution, I don't have any issues with that. So you do whatever works best for you. But I'm going to teach it only one particular way, that way that we can use the same approach to every single problem. Before I show you this, let me say this first. When you remember, the golden rule to equation says whatever you do to one side of the equation, you must do to the other side of the equation. So if you add 3 to one side, you have to add 3 to the other. If you subtract 7 from one side, you have to subtract 7 from the other. If you divide one side by 2, you have to divide the other side by 2. Now, what we've not had to do so far in any of the equations is, what if we multiply a side by a number? Now, this is what I want to talk to you about. Whenever you add a number to a side, if you say plus 7 on both sides, you just add 7 to the number that's already on that side. But when you multiply a side by a number, it's very different than adding a number to a side because of what we call the distributive property. When you multiply a side by a number, if there's more than one term on that side, if there's 2 terms on one side, when you multiply a side by a number, you have to multiply every term on both sides. Now, I'll show you an example in a minute what that means. So how do we decide, why do we multiply, and how do we decide what to multiply by when we're dealing with equations with fractions? Well, let's suppose I had an equation that had a fraction where the denominator was a 5. What I will do is, to get rid of a dividing 5, I'll multiply by 5. Why would I want to do that? So the 5s will cancel out. But if I multiply one side by 5, I have to multiply the other side by 5. Now, what if we're dealing with an equation that has multiple fractions in it? For instance, suppose one of the fractions had a denominator 4, which is a dividing 4. Suppose another fraction had a denominator of 3, a dividing 3. Well, you can't multiply one side by one number and the other side by a different number. So then what do we do in that case? You have to multiply by a big enough number that 4 will cancel with and 3 will cancel with. Well, let's see, 4 and 3 both go into 12. So what I will do is I will multiply both sides by 12. Well, it turns out that 12 also happens to be the least common denominator between 4 and 3. So what we're going to do is we're going to multiply both sides by whatever the least common denominator is for all of the fractions that's in that problem. Now, we're not going to get a common denominator. We're not adding stuff together. We're wanting to get rid of the fractions. And we can do that only if it's an equation. So, let me show you some examples. All right, so let's suppose, give me just a second. So let's suppose I have the equation x over 3 equal 2. First of all, notice that there is only one term on the left, there is only one term on the right. All right, so what I want to do is the first thing I see that I don't like when I see this equation is I don't like the dividing 3. Well, to undo a dividing 3, I can simply multiply by 3. So what I want to do is I want to multiply the left side by 3. But if I multiply the left side by 3, I have to also multiply the right side by 3. All right, so I will show that in red. I'm going to multiply this left side by 3 and multiply this right side by 3. Now, remember when we talked about multiplying with fractions, we said when you're multiplying with fractions, it is always best to cross-cancel first. So you need to remember that in these problems. So before I multiply, I'm not going to say 3 times x is 3x. I'm going to cross-cancel these 3's. 3 goes into 3 one time. I don't have to put that 1, I'm just doing it to emphasize it. So the 3's cancel, which is why we do this, to get rid of that fraction. So I would have 1x, or just x, equals 6. Now let's check this. If you put 6 right here, what is 6 divided by 3? Of course it's 2. So that's the solution to this problem. All right, let's look at another one just like that. So let's suppose I have 2x over 5 equal 4. 2x over 5 equal 4. Well, now what I do is multiply both sides by a 5. But whatever I do to one side, I have to do to the other. Now, when I do this, the 5's cancel. 5 goes into 5, and it doesn't leave a nothing. It leaves a 1. But then 1 times 2x is just 2x equals, and then of course 4 times 5 is 20. Now, if you'll observe, this problem is not solved yet because there's still a coefficient in front of that x. We talked last time about how to deal with that. You get rid of that coefficient by dividing because you're unlocking the multiplication. When I do, the 2's divide out, and of course 20 divided by 2 is 10. Okay, let's look at another example. 3x equals 2, 5 over 7. Now, let me say again, there is more than one way to do these problems. And if you go to YouTube or if you look up videos on solving equations, you may see 4 or 5 different ways to do this. My suggestion would be find the one way that works for you and you stick with it. This is the way I will teach it. This is the way I will explain it to you. And it's the only way that I teach it. So, all right, so let's look at this problem. This equation is not solved because of the 3, but I also have a fraction in the problem. So when my eyes hits that problem, if it has a fraction in it, I deal with that first. Okay, it's a fraction because of the dividing 7. So I'm going to multiply by 7. But if I do that on the right side, I have to do that on the left side as well. Now, 7 times 3 would be 21x equals 2. Now, on the right side, don't say 5 times 7 is 35. Best way to do it is just cancel the 7's, and it leaves a 1 times 5, which is 5. And then there's that coefficient that we have to get rid of again, which will leave me 5 over 21. And 5 over 21 does not reduce. Okay? Let's look at next example. 2/3 x equals 3/4. Now, two comments I want to make about this problem. First of all, the 2/3 x right here, that 2/3 x is one term. I know you see two things here, but this is multiplication. Remember we said multiplication's like glue. It holds a term together. If this was a plus or a minus sign, it would be two terms. So this is considered one term. For instance, if I said 5 A, B, C, D, E, that's one term because it's 5 times A times B, etc. So if it's multiplication, it holds it together. Only when I use the word plus or minus does it separate that into two terms or an equal sign. So I have one term on the left, I have one term on the right. What makes this different is if you'll look, I have a dividing 3 and a dividing 4. Well, to get rid of a dividing 3 and a dividing 4, you can't multiply both sides by a different number. So I've got to multiply by a number that's big enough that they both divide evenly into. Well, in this case, of course, you know that's 12. So I want to multiply the left side by 12 and multiply the right side by 12. You'll hear me say this every time when I get to this point in these problems. Cross, cancel, first. Don't do anything until you divide these fractions out. So 3 goes into 12 4 times. 4 goes into 12 3 times. Now multiply what's left. So 4 times 2x is 8x equals 3 times 3, which is 9. Now we're right back to getting rid of that coefficient in front of that x. We do that by dividing and get x equals 9/8. Okay, let's look at another problem. Let's look at 2x over 3 plus 2 equals x minus a half. Now, this one is a little different than all the others that we've done so far. And the reason is if you look at this equation, it has now two terms on this left side. Now, this is a very common mistake, so be sure you listen to this carefully. Whenever we multiply the left side by whatever we're going to multiply by, I must multiply both of these by whatever that number is. So it's every term on both sides. So let's count them. 1, 2, 3, 4. I have 4 terms. So when I multiply the left side by whatever number I'm going to multiply, I have to multiply the 2 terms on the left and the 2 terms on the right. So let's figure out what we need to multiply by. We'll look at all of your denominators. 2, 1, 1, 3. So 2 and 3 I need to multiply by a big enough number that 2 and 3 both divide into, which of course is 6. So I'm going to multiply both sides of this equation by 6. Now when I do that, I've got to multiply this entire side by 6. That's where the word distributive property comes in. So it's going to be 6 times this, 6 times this, 6 times this, and 6 times that. So what I'm going to do, instead of putting it in parentheses and put 1 6, I'm just going to put a 6 by every one of these terms because it's easier for me to look at. So let's do that. So I'm going to do 6 times this term, 6 times that term, 6 times that term, and 6 times that term. Now, is that the way we do it when we're adding 6 to both sides? No. Is that what we do when we subtract 6 from both sides? No. But that's how you multiply a side by a number. All right. Now the 3 words you'll hear me say again. Cross, cancel, first. So this 3 goes into this 6, 2. There's no canceling here because that 2's in the top. There's no canceling there. This 2 goes into 6, 3. Now let's multiply what's left. So this would be 2 times 2x, which is 4x, plus 12 equals 6x minus 3. Now, if you look now, we did this last time. This is that two-step problem. So, I'm going to try to do it in one step, just so you'll see it again. I really would like for you to get to where you can do this in one step. So what happens? To get rid of the adding 12, you're the minus the 12 over here and here, but it's gone. So you're going to have a minus 12. But you got to get this 6x back on the left side. So you minus 6x, so it becomes a minus 6x over here with the 4x. So if you do this in one step, here's what it will look like. 4x minus 6x equals negative 3 minus 12. Now let me emphasize this again. If you go back to section 2.1, part 1 video, I did a whole bunch of these where we did it in 2 steps. If you have to continue to do it in 2 steps, that's okay. But try to get to where these 2-step problems, you can do it in 1 step. Because we run into these over and over again throughout this course. All right, so we've got negative 2x equals negative 15. Back to that very first video, if you lose 3 and then you lose 12 more after that, you've lost 15. So you really need to know the rules for multiplying and dividing, adding and subtracting positive and negative numbers. Then divide by the coefficient, negative 2. And then remember, a negative divided by a negative is a positive, and 15 over 2 does not reduce. Okay, let's do another one. All right, so let's do 2/3 minus x minus a half equals 3/4 x minus 2 plus x over 3. All right, boy, this one's got a bunch of fractions in it. All right, let's first, before we go any further, let's see how many terms we have. Here's my equal sign. 1, 2, 3. So I have 3 terms on the right. Now the left side. 1, 2, 3. So you have 3 terms on the left, 3 terms on the right. All right, so when I multiply, and now there doesn't have to be the same number of terms on the left than they do on the right. It just so happens that's the way this one worked out. All right, so we've got a dividing 3 and a dividing 4. And a dividing 2. So let's see. 3, 4, and 2. 3, 4, and 2 is 12. So what I'm going to do is multiply through by 12. But remember, when you multiply through by 12, you don't just multiply just the denominators, just the ones with fractions. You have to multiply every term. Yes, this one. Yes, this one. So I'm going to have to multiply all 6 of these by 12. So I'm going to put a 12 here, a 12 here. We do not do this with adding and subtracting, but we do this with multiplying. Now, the 3 words you're going to hear me say, cross, cancel, first. And so that's what I will do now, is I will cross cancel. So this 3 cancels with this 12 and leaves 4. This 2 cancels with this 12 and leaves 6. This 4 cancels with that 12 and leaves 3. There's no canceling here because they're both in the top. But this 3 cancels with this 12 and leaves 4. Now what I want to do is multiply everything else that's left. Now what I'm going to do is I'm right at the 20-minute mark. And again, it's easier for me to upload videos as long as I stay under the 20-minute mark. So I'm going to stop this video now. And I will pick up with section 2.1, part, I believe it's 5, in the very next video.